All right, this section is going to be multiplying and dividing radicals. The last one we talked about how to break down radicals, taking third roots, fourth roots, fifth roots, even square roots of variables and stuff like that. This particular instance, we're going to be doing the same thing, but we're going to be multiplying and dividing, and then we're going into how to do all that operation stuff. This video is going to focus more on multiplying than it is dividing. The next video will be dividing. So multiplying radicals, we need to know a couple different properties. So if I have a square root of A times the square root of B, I actually get the square root of A times B. You'll notice that these are all squares, okay, or square roots actually. The root is a 2. So that's what happens. The square root of A, the nth root of it, meaning the root is 2 or 3 or 5 or 58 or whatever the root is, times the nth root of B is the nth root of A times B. So the only way we can multiply square roots or cubed roots or fifth roots is if the root is the same. Now, in the last video we talked about how to break these down and simplify, and that's what we're going to do once we multiply these together. This right here, this n, is what we call the index. Okay? It's what we call the index. So in order to multiply roots together, the indexes have to be the same. It cannot be a 2 and a 3. We don't get 6 when we do that. It's 2 and 2. We have to have the same roots. So let's get into some multiplication examples here, and then we'll go into the next video with dividing. First two problems up here are as follows. They're both square roots. So a square and a square. So that means I can multiply them according to the property that we had on the last, in your notes, right, that we just added to our notes. The index is a 2, so that means that I get 48 n to the 4. Remember, when we multiply variables, we add powers. 1 plus 3 makes the 4. So now, because I have the square root, I can break it down. 48, 2, 24, 2, 12, 2, 6, 2, 3. So square root of 48 is 2 times 2 times 2 times 2 times 3, and then n to the 4. Because it's a square, I need groups of 2, then 1 pops, crossed, pops, crossed. So the numbers that pop make a 4. This 3 is going to stay inside, and then how many times does the 2 go into the 4? Well, that's twice. So your answer is 4n squared times the square root of 3. Number 2. So I have square root of 10r squared and the square root of 10r squared. I'll show you two different ways to do this one. Maybe the second way will make sense. I don't know. So the first way, we're going to do it like we did in the previous problem. I'm going to multiply 10 and 10. I get 100. And then r squared and r squared is r to the 4. I multiply them together. So a couple different things. We know that square root of 100, if I just take this separately, is 10. And this 2 here goes into r squared twice. So my answer is 10r squared. I have nothing left inside. I just did a quick way of what we did here. Instead of breaking down 100 like I did 48, I just took the square root of 100. So a couple different things. One is that's one way. The second way is if I have a square root and I'm multiplying it by the same square root, then I get what's inside. So for instance, if I have the square root of 10r squared and I'm squaring it, when you square a square root, you get what's inside. We've talked about that before. Okay? That's what I'm doing here. This 2 just means I have 2 of the square roots. So that's what I get. That's why I get 10r squared for my final answer. So that was a little easy one. You might have gotten that. If not, then just break it down with your prime factorization and go from there. Let's do these two here, and then this will pretty much be it for this actual video, and then we'll move on to the dividing ones. Those are going to be a little more complicated. So I want to multiply because these are both square roots. So let's multiply. -1 times 2 is a -2. Square root. 15 times 10 is 150. M squared times m is m to the 3rd power, and we have a square root there. So the index is a 2. So let's take 150 and break it down. So 2 can go into it, that's 75, 3 and 25, and 5 and 5. So I get negative 2 times the square root of 2, 3, 5, 5, m to the third. Right, 2 times 3 times 5 times 5 is 150. So I need square roots. I'm dealing with a pair of numbers, so that 5 kicks out, the other 5 disappears. So the 5 that kicks out multiplies together, gives me a negative 10. I should at this point know that I'm going to take 1m out. The square root of 6, 2 times 3 is 6, with 1m left over. So there is your answer for this one. Let's go to the number 8, where now we have fourth roots. Oh, this is going to be great. Let's multiply numbers out front. Negative 4 times negative 3 is positive 12, times the fourth root of 50 times 40, which is 2,000. Oh yeah, this is going to be great. N to the 5th power. Remember, we add powers when we multiply variables. Now let's break down 2,000. 2 times 1,000. 2 times 500. See, with the 2's, we go small, but we got a lot of different kind of branches here. 2 times 250, 2 times 125. I can't do 2 anymore, but I can do 5. So it's 5 times 25 and 5 times 5. So I can break down, which is 12 times the fourth root of 2, 2, 2, 2. So 2, 2, 2, 2. And then 5, 5, 5, n to the 5th. This is going to be lovely. Because I'm dealing with the fourth root, I need groups of 4. 1 kicks, the other 3 go in the trash. You notice I have 3 5s and not 4 5s. With 3 5s, I can't do anything with it. So the number that got kicked out becomes a 24, 12 times 2. If you look at your n's, you notice you can pull one of them out times the fourth root of what's left. 5 times 5 times 5 is 125. I took one n out. That means I have one n left. Okay, if you have a question with that, go back to the previous video and you can remember how to do variables with different roots. And then this is your answer right there. Boom, that wasn't so bad. Division is the next video. That one will be a little longer than this one.